Yeah.
Finding you, we're just finding you. 7, the last exit before the plaza.
I want to test those products before you ship them. Thoroughly.
Cool there. We can do the production.
No, they actually didn't.
Oh, really? Remember that? Is that still?
Using your money's back.
I used to do the coming home thing where if you got off the Wolf Trap exit, it was free.
Hey, good evening, everyone, and thank you for coming.
I just check Waze and be like, there's no cop sitting near Wolf Trap. Like, they have these like fun states.
Okay. Good evening, everyone, and welcome to this month's iteration of DC iOS. Hope everyone is doing well. We have another great talk lined up, and yeah, let's get right to it. So, quick welcome for those of us who are in person. This is the first time we've been on Capital One's campus since February 2020, right before COVID happened. I think we actually were supposed to host a March meetup, and that was the week everything locked down. So that was right on the edge of, we almost got a March meetup in, but we didn't. So virtual guests, you are muted for now, but there will be plenty of time to unmute later at the end when we do Q&A. So just to kick off quickly, I'm about to hand it off to our speaker to get started. After that, we'll have a quick discussion, some quick announcements, open the floor for any other quick announcements. And then for those of us here, there will be networking. I mean, you're welcome to try to network too over virtual. We can respond in chat and stuff, but let's get it on. So after that, I will hand it off to our speaker, Anand.
Thank you so much.
Yeah, I was back. It felt like
All right, so can people hear me all right? Great, so good evening, everyone. My name is Anand Kumar. Thanks for coming. As you can see, and to state the pretty obvious thing, the talk is on custom instruments. An instrument which is custom instruments. We'll talk more about it, what it possibly means, what can be useful about it. And before we go deeper into the talk, this is the rough agenda of the talk. These are the things we talk about, and I'll tell you just a line or two about what all of these things are, so that you always know where we are exactly at any point of time in the talk. And if something is not making sense, you can always stop me for that. Or if my pace is too fast, my diction is not clear, just let me know. So we'll first talk about what are instruments. I mean, I guess most of us over here are iOS engineers, so we have definitely used instruments at some point of time. But not everyone would have used it. It's not a given that everyone has used it, or you may have used it, but a pretty long time back. It wouldn't hurt to have a quick refresher of how the current instruments app looks like and how do you use it. Once we have done that, we'll have a better understanding of what the term custom instruments mean. We'll talk about that. Then we'll talk about why even make custom instruments, like what's the need for it when we have already got scores of instruments which Apple is providing. Once we have done that, we'll take a small theoretical detour. We'll talk about what are the components behind an instrument. It's pretty theoretical stuff. You'll probably not need it, but you need to know about it because you'll hear the references about this every now and then. Then we'll take a very quick bird's eye view of how to create a custom instrument so that you get a feel of it. Then there's a certain language that you need to know, certain data type you need to know. We'll talk about what those are. Then we'll take a deeper dive into the configuration of exactly how you can make the custom instrument you want to make. How can you achieve the various things you want? And then finally, we'll just take a few seconds and see how to distribute a custom instrument that you have made to other people. That should be it. Looks pretty big. It's not that big. We'll see how it goes. Okay, so what are instruments? I mean, instruments, to put it very loosely, is basically this app that Apple always provides if you want instruments out there. What you're seeing over here is nothing but a standard Wikipedia definition of the word instrumentation. All of us would have heard this word in our academia life. If you want to measure something, that process is called instrumentation. It's an engineering branch by itself. In the world of software development, it means the same thing. If you have developed something and if you want to measure it, that is called instrumentation. Now, Apple provides an app for it. You can launch that app in multiple ways, but once you've launched it, it looks roughly like this. Whole set of things you can monitor over here. We'll look into what all these sections are, what are some shortcuts and things like that. But plenty of things you can monitor over here. What you want to monitor, you select an app that you want to monitor. You can measure those things over here. the icon looks like this thing on the left top, in the bottom left. I mean, it lets you, at this point of time, it lets you monitor, it lets you kind of monitor scores of different things. And yeah, everything that you see in an instrument over there, we'll look into that. Now, how do you go about it? Once you've launched the instruments app at this point of time, I mean, any point of time, the first thing you have to do is you have to select a profiling template. This thing on the left side. There are several standard profiling templates that already exist. And these profiling templates kind of group some related instruments together. You're seeing some of the common templates over here. There is a time profiler, the thing that's highlighted, which is definitely the most commonly used profiling template that you must be using as an instrument, as a iOS engineer. Then there are some more common ones, like there's an app launch, which is pretty handy if you want to figure out how quickly your app is launching, what are the bottlenecks, things like that. We also have file activity, not quite useful if you're not making a Mac app, but it's there. And then this one is very common. There's something called logging over there. If you've got lots of extensive logs, there's a profiling template name is logging. It lets you visualize lots of things pretty easily. And there is also another pretty important and useful thing called network profiling template. Think of it as a loose alternative of charts if you can properly set it up. But the bottom line is that once you launch Instruments app, select a profiling template, or if you don't want to select any profiling template, you can just select a blank. You'll land up on a screen like this that you're seeing on the right side. And the screenshot which I've got right now, for this I've selected the time profiler template. Now, if you see that thing on the left side of this right screenshot, you're seeing three things over there. It may be pixelated for you on your screens, but there are things like time profiler, point of interest, and thermal state. So everything over there is actually an instrument. This entire thing together is an instrumentation session or a recording session. Again, we'll talk a little bit more about it. So you launch the Instruments app, this comes up. And just a quick word on what the various things are over here. So this is the same screenshot as what you were seeing previously, but a more expanded view with some annotations. So everything that you're seeing on the left side is basically the list of included instruments in this particular instrumentation session. So that means what I'm saying is, when I start recording this app, when I start observing it, I want to observe these three things. I want to have the time profiler template running. I want to have the points of interest template running. I want to have thermal state instrument running. Now, do not think much about what all these instruments are. That's kind of besides the point for this particular talk, but everything over there is an instrument of its own. On the very top, you're seeing the target area and you're seeing the process to be profiled. It looks like what we've got in Xcode, but the order is reversed. And in Xcode, on the left side, we see the app the schema you want to run. And on the right side, you see the run destination. Over here, it's slightly different. Yes.
Can you try talking a little more? They're saying the mic seating works a little bit.
Sure. Can people hear me all right now? Any thumbs up? Okay.
They're saying not really, so I don't know what else we can do. Let me take a look at my panel. Just keep going. I'll get the mic tech in
I
here.
try to speak louder. Okay, so what you're seeing at this point of time is the UI of the Instruments app, which will show up if you're launching this application. What you're seeing is basically over here. Just look at the extreme left side. And what you're seeing over there is a list of instruments. What it basically means is that in this particular instrumentation session, once we start recording the app and observing things, those are the three instruments that will be running. That means that those are the three kinds of things that we'll be observing. Over here, it is time profiler, points of interest, and thermal state. What exactly those instruments are is kind of besides the point right now for this talk, but the only thing we need to know is that those are the three instruments running in this session. Then on the top bar above it, towards the left side, we are seeing the target area and process to be profiled. What it means is that the moment I start recording, in that particular simulator or device that you've selected, we will be launching that process. In other words, we'll be launching that app. It will run automatically, and we'll do what we want to do in that app. In the meantime, we'll see whatever happens over here. And now the interesting part. On the top right, you see a button called plus. That is the show library button. If you tap on it, that's when all the instruments that are available for you shows up. Looks something like this. Now, If you tap on the plus button, a pop-up like a modal like this will come up. Not quite a modal, a pop-up like this will come up. It shows you all the list of available instruments. You can drag and drop however many you want, unless you're going crazy over that. And everything that you drag and drop, once you hit the record button, all of those instruments will be in work. All of them will be recording the data, analyzing it, and showing you whatever you wanted to see. Now, these things that you're seeing over here are basically standard instruments that come with Apple. There are scores. I'm not showing everything over here, but there are a lot many more. Now, we can totally move on from this slide, but just a quick word because you definitely need it. Some of these are very common ones. In the rightmost screen, you're seeing something called time to file at what's available. That is, in my opinion and my experience, hands down the most common instrument you'll ever need. There are a few more things over here, like the OS log, OS signpost, network monitor, activity monitor as well. But yeah, for me, time to file has been the most common thing. Anyway, this is the list of instruments you've got. That brings us to the point that what are custom instruments? It's nothing but this. Now, I want to have something of my own over here. I want to record something which Apple will not let me record. I mean, Apple doesn't ship with that thing. Apple doesn't ship with that instrument. I've looked into all the instruments Apple has got. I somehow feel there's something I need, which Apple is not quite providing me. I know how to capture that data, but I need to have a way to show it to the user in the instruments UI. So for that, I can create a custom instrument. It can be something which makes sense just to my app alone, but it can be there. So that is what can happen. So by the end of this entire session, or this entire exercise, if you ever take it, you'll end up seeing something of your own over here. Right now, the example you're seeing is just a standard custom, it's just a custom instrument which I've created called pixels processing. Imagine a hypothetical SDK you've got, which does some video filtering. You ship this SDK to other people. It's doing a lot of stuff, and you want to be able to see what's happening over there in your own visualization. So for that, there's an instrument called pixels processing. Few more things about it, we'll come to it. But this is what will actually eventually happen. So that is what instruments app is. This is what custom instrument basically means. With that, we can come to the next section, that is why make custom instruments. So yeah, that's a pretty valid question in my opinion. Why make custom instruments? As you saw, Apple has got scores of instruments. Almost any conceivable standard generalized thing, you've got an instrument for it. Why would you want to make a custom instrument? The way I look at it, there are two reasons to it, or two kinds of reasons to it. The first reason is, the first reason, which is the most simple, easy, and intuitive reason is just for the fun of it. Here's a quote by a very, very famous scientist. I'll not read what it means, what it exactly is. But the idea is that if you see something, if it's interesting you, give it some time. Even if you cannot think of a practical utility, give it some time. Don't go overboard, but give it some time. Who knows, something useful will come out of it. So this is a simple reason. Something interests you, give it a try, see how it goes. But there's a more serious and practical reason, which is the second kind of reason. So the thing is, if you're creating a custom instrument of your own, you can tell the journey of your code exactly in the way you want it to. You can have your own visualizations, your own narrative, and you will not be constrained by what Apple is going to give for you. I wouldn't say it's totally up to you, you're still using Apple, but it's a lot up to you. And there are some more practical uses of this. Going back to my previous example, it is especially useful if you're shipping an SDK of your own, because imagine you've got an SDK of your own, and you're shipping it to other companies. They're using your SDK. You don't have access to their source code. You don't know how they're using it, but they'll run into issues when they're using your SDK. They'll loop you in to help you debug. You'll invariably get into a call with them. What you could also do is create a custom instrument of your own, give it to them. If they see a problem happening, ask them to recreate the problem, record it in your custom instrument and give it to you. And once they do it, you can pretty much see everything which is happening in just the format that you want it to. And it's pretty safe because when they're sending over that session to you, that session document to you, you only get the information that pertains to your SDK alone. You do not have access to any of their proprietary information, any of their logs, nothing of that sort. So it's pretty safe for them. It's pretty safe for you. And yeah, you can have your own visualizations and a few more subsidiary benefits. Something like you don't need to be compiling that every time you want to observe something. Just launch instrument and see what's happening. You can see it. And there's also a few more things. You could say that, okay, fine, why do I need to go through all these kind of things? Can't I just have my own elaborate logging mechanism and look into it? You could do that. But if you want to do something very sophisticated, you might end up writing a lot of code just to have the kind of logs you want. With this, you may still have to write that code, but that code will not reside in your source code. It will reside in your custom instrument. So maybe there's some clean code which you can achieve with it. So that is one way to look at why you need custom instruments. That's my take on this, and now we can go further. So what are the underlying components? Now, the thing which I'll say right now is pretty kind of obvious, but we need to know that anyway in this topic. So instruments by itself is an app. Any app has got an architecture of its own. In other words, any app has got some of its own components. What are those components? Now, this is something we have taken exactly from the WWDC talk, which introduced this topic. And again, what we're saying is nothing kind of it's not something which you would have never guessed, but they told it anyway, and it's worth repeating. So instruments, the app has been around since forever. Since the time I have known iOS development, or even before, I have known instruments there. I can vouch for this thing being there at least 13, 14 years back. It might have been there even before. It might even be predating iOS apps. It's there. Now, initially, there were not too many instruments. And the way it used to work is that every instrument that Apple used to develop, it used to have its own mechanism, its own recording mechanism, analysis, storage, and UI. Any new instrument which comes up, they have to write their own UI rendering mechanism. If they want a new kind of a graph, they have to kind of write all the code for it. That was, of course, not sustainable, not practical, because with every passing year, especially as iOS kind of really spiraled, more and more instruments kept getting added. It was not sustainable. You can't expect every single instrument to have its own stack from scratch. So they kind of unified many various things over there. And now what they say is they basically use two terms. There's something called standard UI, something called analysis core. Again, these are things which you not typically need to know, but it's good that you know these things. Now, standard UI is nothing but the rendering engine. This is the piece which takes all the data from the databases, puts it in the UI that you're seeing, be it the graph on the top or the detail in the bottom. Analysis core is probably the meatier thing. This is where it's working with the database, it's having an expert system of its own, it's doing all the necessary optimizations, and many more things. These two work together to show you the UI that you actually see. So just keep in mind, standard UI is a UI piece, analysis core is a database storage mechanism. You will see references to this every now and then. Now it gets into some more practical things. So analysis core, what's happening with instruments is that you're seeing a lot of data over there. And anytime you're seeing data, somewhere there are tables in which lots of information is being stored. That's how it always goes in software. Here as well, in analysis core, there are plenty of tables. If you're creating an instrument, you have to basically, at some point of time, you have to say what tables you want to work with. So analysis core is where all those tables reside. I'm saying this in a very kind of a generic way, but it's not incorrect. That's what pretty much analysis core is to begin with. It does lot many more things, but this is the most elementary thing it does. There are plenty of tables. It lets you define those tables, and then does all the hard work of storing data into the table, lifting it from there, passing it to standard UI, and things like that. Now, these are some sample tables which already comes with Apple. Apple instruments built in. We can use it, but these are just some examples. There are scores, I don't know, hundreds of many more tables. Now it gets even more practical. So once we are making a custom instrument, we will have to define our own tables. We'll have to do it at some point of time. Now, anytime you're defining tables, before we define tables, we'll have to define some schemas. Schemas are nothing like a chassis for the table, or basically a structure. And anytime you're defining a schema, you will have to define how many columns you need in that schema. In this example, you've got a column 1 and column 2. And for every column, you will also have to indicate what kind of data should be there in this. Is it an int, string, something like that? So these things are needed. What exactly those data types are, we'll see it very shortly. But just keep in mind, for every schema, you need to define how many columns you need, what kind of data needs to hold. There's also something called attribute after that. Now, strictly speaking, attribute is not something which belongs to a schema. It actually belongs to a table. And for any table that you're defining, you can have some attributes as well. That means this entire table, I want to have attribute 1, attribute 2, which basically are some key value pairs. That's what it is. So if there's something very generic to the entire schema, you can put it in an attribute. You would typically not need this, at least I've not needed it, but you can do it if you wanted to. Just keep in mind, attributes go to the table and not quite to the schema, but the columns go to the schema. Okay, so we have talked about what the underlying components are. Just as a refresher, there's a standard UI, there's an analysis core. Inside the analysis core, you have to define schemas. Inside the schemas, you have to define the columns. Now let's get a feel of how this entire thing looks like. I mean, if you want to create a very bare bones essential custom instrument, what it will look like, what the process will look like, how it will feel by the end of it. Let's take a quick walkthrough into it. So the way it goes is just how it goes if you want to create any project in Xcode. You open up Xcode, you select the option of File, New, Create New Project. This familiar template comes up. Usually you'll go to the iOS template and select something from there. Over here, the template to be selected is macOS. Scroll down, or you don't have to scroll down, but go to that other section. There will be something called Instruments Package. Select that. The moment it happens, an Xcode project will kind of load up for you. Very simple, nothing complicated looks over here. And I mean, there's just one file on the left side, and there's nothing else. The file on the left side is where everything will actually go. And that is called the parlance for that is instrumentation package. That's what they call this file format. It's actually nothing but an XML. But this is the XML where everything will go. What schemas you need to have, what tables you need to have, how do you want to store the data, and plenty more sophisticated things if you ever need them, if you ever need to. I've not mentioned what those things are, but even those, in my experience, I've seen everything go over here. So that's it. You create a new instrumentation package project of the type macOS template. Project like this loads up. There's an XML over there. You put things in this XML. Now, Xcode does offer you. Now we look into what all these fields are. That's what this talk is actually about. So no need to kind of wonder what that is, what this is. We look into what many of these fields are. Now, Xcode does offer some code completion over here, but nothing too great. Maybe it'll improve with time, but nothing too great. But it does offer you something. And yeah, there is documentation if you want to look at that. Anyway, this comes up. Now, then what you do is you run the project. That's what. Do the command R you've always done. You modify the XML. Once you feel that you've gotten the XML you wanted, just do your run the project, command R. And once you do a command R, if you're running a project for an iOS app, simulator launches. Over here, instead of simulator launching, an instruments app will launch. Practically exactly like the real deal instruments app. The only thing is that it will have, if you see on the left side, it has got a grayscale icon. So it's actually a different process. They're launching a different instruments app, which is like a debug version of it. It'll behave exactly like an instruments app. The same profiling template comes up with the same set of options. Everything you've got at your disposal over here. Over here is like the blank template. And then once you've got the blank template, go to the library and your instrument will be right over there. Then drag and drop it, start running it, start recording it, and you'll see whether your instrument is doing what you need to do it or not. So that's how it feels. I'm guessing no questions so far. Okay, now before we really go deep into that XML, a few small things we need to be aware about. There's a certain language at work over here, and there's a certain data type. So the thing with custom instruments is that you really want to do a lot of modification of your own before you can show that thing in instruments. Usually you need a certain language to do this modification. Now, that language is not your normal Swift or Objective-C. It's something else. We'll see what it is. There's also a certain data type you need to work with, which Apple has, I think, built on their own. We'll see what that is as well. The language is something called Eclipse. It's a language which NASA created in mid-90s for a lot of their AI systems. I don't know if they're still using it, but I think it's actually being widely used right now in the software engineering industry, a lot of AI-related work. For some reason, this is what Apple uses for your custom instruments. If you go to this website that I've listed over here, eclipserules.net, there are some very exhaustive and very clear and nice tutorials and references over there. And this language is a proper language of its own. It has got enough happening over there. The good news is that you don't need to know all those things over here. Just a few things you need to know, and I think it's enough. And if you look into any Eclipse code, if you just try to read it, I think you'll understand what's happening over here in that code base. The only slightly different thing is that it's a prefix notation language. That means if you look into the screenshot that I put in the bottom, it kind of works like that. If you want to do any kind of operation, the operator goes first, followed by the left-hand side and the right-hand side. And yeah, every variable has to be prefixed by this question mark sign. So prefix every variable with a question mark sign. Put the operator followed by the left operand, followed by the right operand. So if you wanted to do A divided by B, instead of doing A slash B, you'll have to do slash followed by question mark A, followed by question mark B. That should be it. I don't think you need to know much more about this language unless you're totally into this. Now, coming to the data types. So when you're creating custom instruments, you'll have to define schemas. Anytime you're defining a schema, you'll have to define plenty of columns. For every column, you'll have to specify data type. Now, that data type is not a primitive data type. It is something which Apple has made for instruments in particular. And they've given it this generic name called engineering type. That's what it is. Now, all columns, in every column that you define for any schema, you have to specify an engineering type for it. Every engineering type, in turn, is backed by Eclipse data type. You don't have to specify this Eclipse data type yourself. I don't think you have to deal with it either much, but you need to know about it. And below that, I've got just a screenshot of the Apple's official reference. If you go to this web page, you'll find all the engineering types they've got. And there are plenty. There are scores. There might even be 100 data types over there, and they're kind of classified into categories. So if you want to work with memory, there are certain types for that. If you want to work with time, there are certain types for that. There are things. And it's not too difficult to navigate. If you go in, you can search, you can find it. Now, regarding this engineering type, there's one more thing we should know. Okay, how it looks. Yeah, how it looks. So over here, what I'm showing you is basically a snippet from the XML. So I've got an XML, which we'll look into. In that XML, I'm saying that I've got a schema. That schema needs to have these two columns. On the top, there's something called pixels received. And the bottom, there's something called pixels processed. Let's look into the bottom ones. I'm saying there needs to be a column called pixels processed. And in that highlighted portion, I'm saying its type needs to be size in bytes. What it means is the engineering type for this column has to be something called size in bytes. Now on the right side, I've got a screenshot from Apple's official reference where they're explaining this type. So they're saying, yeah, there does indeed exist a type called size in hyphen bytes. That's the identifier for it. Its associated Eclipse type is integer. It's of this category memory. And then there are things like display width. That means if you see, what it basically means for Apple is that if I ever encounter a type like this, and I have to show this in Instruments UI, it'll take this much of column width. So that is why they have got things like this. And simply Eclipse type was not sufficient for them. But the point I'm trying to put across is that anytime you need a certain type in your pixel in your custom instrument, go look in the Apple developer reference, and you can find the exact identifier for it, and then use it. And then if you've got further questions, come back over here and you can see what exactly is the underlying Eclipse type. So that was engineering types. And again, there are scores of types. We do not need to know about all of them. Okay, so we have covered a lot. And now we are finally down to the main part of this entire thing, which is making a deeper dive into the XML and letting it achieve whatever we wanted to achieve. So let's see. Okay, so before we do a config deep dive, that means a deeper dive into that XML, there's a few more things we need to be aware about in the Instruments UI. Now, again, these things were not very obvious to me when I was starting out, because I've been using Instruments quite a bit at various points of time, but not exactly in this way, not exactly in the kind of UI which used to render this thing. I would have seen these things once in a while, but it had not registered to me. So the thing you need to keep in mind is that anytime you bring up the Instruments app, there are two sections to it, a top section and a bottom section. The top section is what is known as the graphs view or the track view. The bottom section is what is known as the details view. Now let's look into the top portion first. Now this screenshot, I'm not very sure how clear it is on the zoom, but if you try reading into it, in the top left, you've got something called pixels processing. That is the name of an instrument. Right next to it, there are two things stacked vertically. There's a bytes received, there's a processing rate. For bytes received, I've got a graph of its own happening next to it, which looks like a histogram. For processing rate, I've got a graph of its own, which again looks like a certain kind of bar graph. Now, both of these things, bytes received and processing rate, they are lanes. There are two lanes over there. So the instrument is pixels processing. It has got a graph, and that graph has got two lanes. So you may think there are two graphs over here. Actually, there's one graph, and that graph has got two lanes. That is the parlance they use. Now, it does get a little more confusing because one instrument can have multiple graphs. And the way you do it is by actually tapping on the drop down, the thing which I got highlighted over there, and changing it from there. So one instrument can have multiple graphs. Every graph can have multiple lanes. And you can do what you wanted to do. And keep in mind, of course, there can be multiple instruments in a single session. So that was about the top view, that is also known as the graph view or the track view. Now there's a detailed view. Again, in detailed view, there are plenty of things that can happen. What you're seeing over here at this point of time is the simplest possible thing. That means you see a table of data over there, a tabular representation of data over there. Now, over here as well, if you see in the left corner over here, I'm having an arrow up to that place. And that is basically a drop down of details. That means I can have many different details in a single instrument session. I can define all of that in my schema. And every detail which comes up can have a different representation. It will not always be tabular like this. It doesn't have to be. So just keep in mind, a single instrument can have multiple graphs. One graph can have multiple lanes. And also, when it comes to the bottom part, a single instrument can have multiple details. And every detail can be of different type. So yeah, that's it. That's all we need to know right now. Now move on. StartAccent. Now this is what I've done is that this is practically exactly the same XML that I had over there. I've just opened that in Visual Studio because Visual Studio allows me code folding on XML. Xcode does not. I folded all the main tags, and I'm trying to show what kind of things you need to define over here. So for a bare bones custom instrument, you need to define a schema. On the very top, we look into that in some more details. For a given schema, you have to define what columns that schema needs to have. Once you've done that, you're pretty much done with your schema definition. Then you start defining the instrument. In the instrument, you have to define your tables. Now, you may think, why do I need to define tables when I've already defined schema? For some reason which I'm not totally understanding, you have to do it. And all you will end up doing over there is that you will say that this table has got this schema reference. Now, as I talk about it, I do know that in a single XML, you can have multiple instruments defined. You may want one schema to be referring, to be kind of feeding data into multiple tables. So yeah, that's how you do it, and that's why you do it. Anyways, for a given instrument, you define tables. After that, for that instrument, you define how many graphs you want. Then you define how many details you want. Now, inside every graph, you'll define your lanes and all that, but this is roughly how it goes. I'll move on. Okay, so now we look into some code base and see how it translates into XML. So on the top, I've got a code snippet from Xcode. If you're familiar with Signposts, it's some very elementary logging mechanism. You don't have to be using Signposts. You can use other logging mechanisms as well. But for the purpose of this talk, let's just look into this. On the top, what's happening is that I've got in the penultimate line, I've got an OS signpost begin. And the final line, I've got an OS signpost end. Begin is where I'm saying, this is my beginning marker of something which I'm interested in. End is where I'm saying, this is the end marker of something which I was interested in before. And I'm specifying exactly what I was interested in. Now pay attention to one more thing. In both the penultimate line as well as the final line, in the final argument that you're seeing, there's something dynamic being passed over there. I'm saying, I'm processing something right now. These are how many pixels I received in the begin marker. In the end, I'm saying these are how many pixels I ended up processing in the end marker. The key thing is something dynamic was passed over here. My custom instrument needs to be able to parse it and do what it wants to do with it. That's it. Anyways, that was the code base. Now coming to this bottom section, the schema definition. Now, just a small pause over here. Anytime you're defining a schema, you can actually create a schema of your own. But creating a schema of your own is not all that simple, at least to begin with. You have to do plenty of things with it. What Apple has also done for us developers is that they have given us some standard schemas, which we can import, and which lets us take care of many standard things. If you're working with signposts, there is a schema for that. You can simply import it like that. It's called OS signpost interval schema. You can try autocomplete, it will work. There are certain schemas which you think will not be available, but if you use a certain compiler flag in your projects field settings, it will be available. But anyway, there's course of schemas as well. If you're working with signposts, you'll use this thing. Let's use this right now for this purpose. So that is a schema which I'm importing. In the beginning, there are some pretty standard things, which the moment you glance, you'll understand. I'm giving some kind of definition for the signpost, like what was the name of the signpost, what is the subsystem category, things like that. Nothing very interesting, but nothing which you can afford not to use either. Then something interesting is happening. I've got a tag called start pattern. I've got a tag called end pattern. This start pattern will exactly correspond to that begin marker of the signpost. That end pattern will exactly correspond to that end marker of the signpost. And then if you see inside those tags, inside the message tag, nothing is happening. I'm trying to pass that exact message which was being logged. So I'm saying, at least with the begin marker, I'm expecting a message to be logged, which will be of this format, a static string called pixels received, followed by something which I want to put inside a variable. And that is how I'm putting it inside a variable. If you see, that is exactly the clip syntax that we were talking about. A question mark followed by pixels received. That means anytime you're seeing a signpost log like this, please store it in your databases and also store that value, that dynamic value in that variable. I will be using that variable subsequently in this XML as I want. That's what happened over here. So that's a start pattern, that's an end pattern. And after that, little further below that, I've got this marker called columns definition. Now I start defining my columns. I've defined plenty of columns over here because I wanted to. But we can look at this one right now. I'm saying this schema needs to have a column called processing rates classification. And it's just a mental model. If I'm processing 70% of the pixels or more, I want to say I processed a lot of pixels. If I didn't have to process that much, I'll say I did not have to process that much. I processed less pixels. So again, what's happening over here is that in the expression syntax, in the expressions tag, there's a complete clips expression over there. And over there, what I'm doing is that I'm calculating what percentage of pixels were processed. If it's more than 70%, I say it's large. If it's less than 70%, I say it's small. But this right here is a very beginning elementary example for you of why you need to know a little bit about clips. Now, again, a side comment. If this thing really interests you, at some point of time, you'll start creating something called a custom modeler. And if you're creating custom modeler, you'll have to work a lot with clips. But if you don't need to, this is what you need clips for. And yeah, again, in this column, if you see the preceding statement, the type was event hyphen concept. That again is an engineering type. If you look up in Apple's official documentation, you'll see that thing. And you'll see exactly what the width is, what is the underlying clips data type. For what it's worth, the underlying clips data type for this one is string. But anyway, this is what the schema definition in the XML looks like. Okay. Now, we looked at the schema definition. I've collapsed that part. Now we're looking into the actual instrument definition. Keep in mind, there can be multiple instruments in the same XML. Here I'm defining one instrument. Again, in the top, nothing too interesting, some pretty simple stuff. You look at it, you know what's happening. That is the name of my instrument. This is the description of my instrument. You can supposedly give a different icon over there as well, or something of your own. If you don't want to, generate is enough. It will come up with a generate icon. Standard stuff. Then the tables definition starts. Inside the tables definition, there we have got something called create table. You have to do this. Even if you've got a schema defined, you have to kind of still spell it out. I want a table to be created. This table, please base it on so and so schema. You have to do it. Otherwise, it will not know it. So what here I'm saying that I want a table of this name, events-table. Then there has to be the schema it needs to reference is that pixels-processing-schema. It's the same identifier I used before. If you tried something before, it will actually throw you a syntax error. So you define that, so you create the table over there. And after that, I've defined my graphs and tables. This is probably the time where you spend the most of time. This is probably that place. We'll look into that in the next slide. Okay, so the next slide, and we now start talking about how you define your graphs. Now, before we look into how you specify your graphs in the XML, just a quick word into what are the various kind of graphs which Apple allows you to render. And these are the three kinds of graphs. There's something called plot, there's something called plot template, there's something called histogram. Now, all of them are pretty much time-based things. That means on the x-axis, time is moving, on the y-axis, that's happening. But how that thing is happening, how it's being rendered, that's what these things are. Now, it's a little difficult to exactly explain what the difference is, but I'll tell you like this. What happens with plot template is that if you, for some reason, you want it so that every new value that you see in a certain column of your certain table, that should be a lane of its own, that's when you use plot template. Otherwise, plot is fine. And when do you use histogram? When you've got discrete data spikes happening, discrete occurrences happening of something you're interested in, like some state changing, you can use this histogram. So these are the three graphs. Now, again, there's a bit of a catch over here. You may look at this plot and you will feel like this is how the plot will always look. This is how any plot graph will always look. I think what happens is that this is how the plot graph usually looks. How exactly it will look depends on a few more things, on what is your schema type, what kind of data types are there, things like that. But just know this much, it's usually enough. Mostly, if you're working with plot or histogram, it's enough. If you want, we can definitely venture into more things. Now, how do you specify it? So this, again, is that demo sample instrument which I've created. In this, there are two lanes. There's bytes received, there's processing rate. There are two graphs as well, but in the graph that I've selected, there are two lanes. Something on the top, bytes received, something at the bottom for processing rate. Now, if you look into this XML, what I'm saying is that there's a graph XML tag, and I'm saying the name of this graph has to be events rate. That's what you're seeing in the popover over there. Inside this graph, I want to have two lanes. Something called bytes received, I've defined it over there. Further down, there's something called processing rate, I've defined it over there. Now, in the bytes received, I'm saying that I want the graph to be of the type histogram. And the processing rate, I'm saying that I want the graph to be of the type plot. Now, depending on what you want your graph type to be, the subsequent tags will change. Again, autocomplete will help you over there. If you want histogram, you have to specify how often you want the data to be pulled. That's what goes in nanosecond per bucket. Now, there are a few more things over there. There's sum as well. I think that's a column which is used to specify where your y-axis will go. And similarly for plot. Again, these graphs, if you want to talk more about it, exactly how can I achieve exactly the graph I want, it'll take some more time to talk about it. But I'm guessing you get the idea of it. You specify, this is how you specify what kind of graphs you want. Now, coming to details, in graphs, there were 3 different kinds of graphs that you could achieve. In details, there are like 5 different kinds of details that you can achieve. We'll see all of them one by one. The simplest one is a list, which is basically a list of things, a list of rows, a list of columns on the top. If you've got certain tables, those tables have got plenty of columns, you can just show them over here, exactly verbatim. Or if you want, you can also kind of do some elementary modification on that data and then show it over here. So this is what list will look like. Again, it's a simple tabular representation of data from the analysis code. The next one is a little more interesting. Again, the previous one, it may not look interesting to you, but this is what will usually suffice. This one is a little more interesting. It's something called aggregation. Now, what this does is that, without again getting into too much of details of that, you'll keep logging things over here. As your app is being recorded, things will keep getting piled up over here. But you can say that there's something which I'm really interested in. For example, there's a certain column over here. I always want to know what is the maximum time duration that I'm seeing over here. And I want to see it at the top. Or in this case, what was the minimum duration? I want to see it at the top, minimum duration. So you can specify those things in the XML that I want to generate an aggregation detail. And I always want the minimum value of my column to show up over here, or max, or a few more arithmetic functions. All that will happen. So that's what aggregation lets you achieve. I can show you a demo for it, but that's what it is. Now, there's a call tree. This is exactly like the call trace, like the stack trace that you would have otherwise seen. So Apple even lets you have a stack trace like UI of your own, if you wanted to. This is the detail for that. Then we've got narrative. It's a little more complicated. It looks pretty simple. What they say is that this is simply, if you simply want to log some messages and show it over there, you show it to the user, that's what it is. I've seen a few more things happen with it, which I've not totally been able to make sense of it. But yeah, it's there. We can talk more about it if you want. But again, if you simply wanted to log messages and show that in detail, you can use it. It will work. It will not be a problem. And the final one is time slice. This is a little kind of specific. what this lets you do is that as the graphs are getting plotted on the top, if you want details to be shown only for a particular time period, like a small time slice in it, this is the thing that will let you do that. And yeah, this blue thing that you're seeing, that's the inspection head. You can move it left and right and switch that you wanted to. So those are the 5 kinds of details. Now we can look into the example of how some of them are rendering. I see that we are probably running over time. I'll try to make it quick. Anyway, going back to the XML, this is the detail section. What I'm saying over here is that in this particular custom instrument of mine, I want 3 details. I want list, I want an aggregation, and yeah, I think the screenshot is only showing 2, although I had one more, a narrative as well. So for the list, what I'm saying is that that is the name of my detail, pixels modify list, and I want those columns to be shown. Something called start, duration, processing rate, no processing rate, and so on. And each of these things need to correspond to a particular column in your schema, in your table. Or if it's a single column table, it needs to correspond to the table. I mean, if you try putting some other name over here for which there is no column name or no table name, there will be a syntax error. But give exactly the name and we'll show that thing to you. Then I've got aggregation. What I'm saying is that I want an aggregation view as well. And I always want to be seeing what is the maximum pixels I've ever seen. That thing towards the bottom, the sum tag. So that's how details goes. Okay, so that kind of brings us towards the end. And I'll run probably a 1 minute or 2 minute demo over here. We'll see how this thing entirely feeds once we are running it. So let me see if I can run it. Okay, so I'm running it. This is my pause it for a bit. So that was my XML. I've specified all the things over there which I was speaking about. I've run it. Debug instruments app is launched. I select the blank template. I go to the instrument library. I look for my custom instrument. I drag and drop it. I select my process, that is the app I want to monitor, and I hit the record button. The app shows up. I'm not showing you that. And now if you see over here, the graphs are getting red. Oh, sorry. The graph is getting rendered on the top. In the bottom, my list view is populating as in data is coming in. I go to the detail view, I change it to custom aggregator. And if you see that on the top, the pixels received column, the top header of that will keep changing dynamically by itself. So that's an arithmetic function. You can have many more things. You can go to the top again, go to a different graph, that will show you something of your own. And you get all the instruments, features, and UI that you otherwise get, all the tricks that you may be having, like pinch, inspection head, and many, many more things. So that's how it goes. That was the demo run. So everything that we talked about, this was a quick run of that. I can play it again for you if you want, but I'm guessing you got the idea of it. So that's how it goes. And yeah, there is something called instrument. Sorry for that. There is something called instrument inspector as well. That means for any instrument session that you've got, you can press Command I or look up this option called instrument inspector in the menu. Pop over like this will come up, a modal will like this will come up, and you can actually look into all your tables, all the tables that were created. How many rows one went into that? If you want to debug, this is how you do it. And if you're working with something called custom modelers, which we have not touched about, you can see those as well over here. And yeah, that pretty much concludes my talk. The final word on how to distribute any custom instrument that you've made. So the way you do it is pretty simple. You go to this option called product show my product. And then if you go to the debug directory over there, inside the build folder, you can see this file over there, instrument distribution, instr.dsg. Send it to whoever you want to send. They can double click on it and they can install it. And once they install it, it starts showing up in their instrument, in their real instruments. That's how it goes. I do not think you need any kind of signing for this, although I've never had to. But that's it. These are some of the useful resources if you ever want to explore more on this topic. I wouldn't say these are like mind-bogglingly great resources, but these are the best things we've got. In fairness, the documentation that Apple has provided is pretty exhaustive. Also, in fairness, the two WWDC talks we have got, you can totally see that they are really putting a lot of effort to explain everything that they can. So I would definitely recommend that you watch those videos as well. They're really very good. And if you still want some tutorial or some people kind of speculating or pontificating on this topic, there are 2 more articles on the internet over there. I think that concludes my talk. Yeah, it does. Thank you.
And I know we've had two questions come in during the talk, so I'll ask them. So first, Franklin asked, is it one graph equals one details view?
No, it is not. So if you've got a 1 pixel instrument, you can have multiple graphs in that. You can have multiple details in that. And the number of graphs and number of details, there is no mapping between them. You can have however many that you wanted to.
Cool. And then Ed asked, are signpost threads safe?
Are signposts thread safe? So I think they are. Although that, in my opinion, that's more of a question for the signpost API than the instrumentation topic.
Yeah,
but
okay.
I think it is. I think it is.
Okay, and Ed actually asked, what got you into custom instruments? What was the motivation or task?
The second word in that, instruments. If you're a developer, you'll probably be automatically attracted to things that are not easily understood. Instruments are not easily understood. There's no great documentation for it that you can just start following and you'll know everything about it. Unlike, I don't know, UI view development, table views, or whatever, whichever way you started. So instruments have always intrigued me. I've always tried following this topic. And if they let me create a custom instrument, well, that's great. Yeah.
In your example, the logic you had for like the pixels processed divided by pixels received
Right.
was a fairly straightforward arithmetic expression that you put inline in your XML.
Yes.
Is it possible to have like more complex logic or
Yeah.
I don't even run a process or something to do that processing?
Yeah, so it is possible to have a lot more complicated things. Hopefully you'll not need them, but if you need them, that's where when you write a custom modeler of your own. And the moment you're doing it, you are working a lot with clips. The good news is that there is at least something that can help you out. I mean, I've delved into it, but if you want to start afresh, this thing that you're seeing in the third icon from the top, that's a dub talk. So you'll get it, and I don't know, maybe if you tweet them, they'll help you out. Yeah.
Okay, my non-serious question is,
Yes.
what about Just for Fun? Was that from Richard Feynman's autobiography? Because that sounds familiar.
No, it's not him. I can tell you who it is after the call. After this talk.
The serious question, I'm still trying to connect the dot on how exactly it all works, especially the part, how do you get from running apps to data in your custom schema? How does that data even get in there?
So you're saying how the data is getting over there?
Yes.
Okay, so right.
Table. I would expect maybe your code has to have custom logic to interface with that table. Or
Yeah,
something.
right. So I'll go back to that slide. And what happened is the example that we saw, that was for signposts. Signposts are for basically this mechanism for logging data. Let me go back to that, please. Yeah. So in this slide, on the top, I've got something from my actual source code. That is my SDK's code. That is where I've got my signposts specified and things being logged. The bottom is the XML. So when I run the app, that code on the top is running. It is logging things over there. And it is actually being interpreted by my modeler and fed into my instruments. And then my XML is telling instruments how to read that thing, how to pass that thing. So this is for signposts. This is not what will always work. But if you're working with signposts, this is what will work. Again, in fairness, I think usually signposts will be enough for the kind of things that people are usually doing.
So it's connecting through OS log to get that information?
OS log, so OS, you're talking about iOS OS, capital O, S
Yeah.
log, right? Okay. So I think this world of instrumentation or logging in Apple, again, has exploded over the last 4 or 5 years. There are many different APIs which exist for that. OS log is one. Signpost is yet another. There's yet more newer one, something called signposter. If you're working with OS log, there's a different scheme of it. Yeah.
Pixels received, that process, where do those come from?
Okay, so you're talking about, okay, I'll point fingers over here. You're talking about this line over here.
Uh,
Okay, so what I'm saying is, in this XML, what I'm saying is that as and when data gets stored in my tables of instrumentation, I want you to look, I mean instruments, I want instruments to look for any signpost which is having this particular spec. Whose subsystem is this, category is this, name is this. And if you see a signpost like that, read its message. What is it logging? I'm expecting it to be of this format, where there'll be a static string in the beginning and something after that. Whatever is there after that, I want it to be stored in this variable, pixels-received.
wow. Okay.
Yeah, so I don't know how many pixels I'm receiving every single time, right? Whatever it is, for everything which happens, that value, at least for this particular XML, for every occurrence will be there in this variable. I've got a variable like this, I've got a variable like this, and later I'm using these variables to calculate the formula.
Is it accurate to say that like you're defining this template, which is being used to filter the logs and you're matching on things essentially?
Yes.
And
Select variables out of that.
yeah,
In the simplest possible explanation, yes. If you go into custom modelers, there'll be more happening, but this is definitely accurate, what Steve just said. Yeah, I can share this sample project with you.
Yeah,
There's nothing proprietary about it.
looking now, that was not obvious on the first pass at all.
I'm glad you asked that question because I too was like, how does it?
Yeah.
Is that matching on a regex or is something about that 90s API that it's doing?
Something about it. It could be regex, it could be something else. I would guess it's regex. I don't need to. You can pursue it definitely, yes.
At some point, you trust Apple, it doesn't work.
Oh yeah, I was more just wondering if there are other patterns that you could provide or like provide matching logic against it.
Okay, I've not tried putting any sophisticated regex over here. For what it's worth, maybe it will work. It's worth a try. Again, it depends on how deep you go into that. What kind of.
You're talking about how it goes from the camel case at the top to with the dashes, like you're saying that matching?
No, I was saying like up in the code, there's pixels received and the %LU,
Right.
but down in the pattern, it doesn't have like the %LU thing, right? It just looks for pixels received
So
space.
that has again got something. So when I'm saying percentage LLU over there, what I probably mean to say is long consonant. Now over here, I'm saying that it needs to go into this variable. If I later on try to use this variable in some other column whose engineering type doesn't match with this kind of a type, then there'll be problems. So don't parse it, but then try to use it like a string, as if it's a string. So any more questions, let me know, no matter how, whatever it is. Because it's quite possible there's something which I've not explained properly, I can do it again.
Thank you. I am just dropping some stuff in the Zoom chat quickly. While I get ready to share. Hi, so some quick announcements. I dropped all these links just in the chat now. If you're interested, there's a Google link here that will go to a Google Drive where we will keep track of it and then reach out to you about timing. We will eventually post this video for this meetup on our Dev Community YouTube channel. We've already posted all the previous ones, including last month's talk. We also do have a Slack workspace. It's a little quiet, but hopefully we can kind of get some momentum going back in it now that we're doing in-person meetups. This is new. We now have a Mastodon at DCIOS at iOS-devs.space. So if you're on Mastodon, please follow it. We still have a Twitter account. I haven't used it that much, but it still exists. And finally, we have stickers. And kind of before we kind of end and go to networking, I want to open the floor for any other announcements. I'm going to start with one. Paul, I'm going to put you on the spot. Our co-meetup group, iOS Soho, they have a meetup this Thursday, I believe. So you should definitely check it out. It is also hybrid, I believe. So, but if you're in the New York area, you should definitely go check it out in person. I don't know if you want to speak any more about what's happening at Thursday's meetup, Paul. Oh, he makes the.
Sorry,
building.
I was muted. I was not ready. But yeah, we're having a meetup on Thursday in New York City, actually in Brooklyn. It would be also. Oops, I can hear
Yeah, you
myself.
get that.
Okay. It will be also on stream and recorded. We have two talks on Thursday. One is about learnings in. Sorry, I'm not even sure about the topics anymore. One is about Swift UI learnings in production, and the other one is about Firestore and how to use Firestore and Firebase in a production application. And once you start scaling, so two very interesting topics. You should definitely join. Thank you, Scott, for the announcement.
Anytime. Yeah, unfortunately, I can't make it, but I will definitely try to catch it after the recording after the fact. All right, and with that, I mean, this is pretty much tentative, but I think the plan is our next meetup will be April 9th. We'll be back at Washington Post, thanks to my co-organizer, Mac. And the topic will be how to cut fat and bloat from your app, which will be given by Mohammed Fani over at Comcast.
I think that date is, sorry, real quick, isn't it like April 11th right now?
Yeah, you're right. That should be May 9th. Thank you. So that would be May 9th. Yes, good call.
It was a great talk.
It was a great call. We've already traveled back. Yeah, but that will be May 9th. So thank you for catching that. And with that, that brings us to the end of the meetup. We'll have some time to network and hang out. Thank you everyone for coming, and we'll see you next month.
That's right.